Jai Hind everyone, my name is Ankita Rani. I am working as an assistant professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Today we discuss the topic requirement engineering process, and that topic comes under the subject software engineering. Subject code is KCA 601. So, before we discuss requirement engineering process, first we have to know what is requirement engineering. So requirement engineering, basically in this, we talk about the requirement of any project, requirement of any software. So the process of finding out and analyzing, documenting and checking these services and constraint called requirement engineering. So basically requirement engineering is a process of collecting the requirement of customer and analyzing these requirement. After that, we document these requirement, and at the last we check these requirements. So requirement engineering produces one large document which is written in a natural language and contains a description of what the system will do. The input in the requirement engineering is problem statement, and the output is the SRS, software requirement specification, which is prepared by the developer. So the requirement themselves are the descriptions of the system services and constraint which is provided to the user. So there are the 5 types of requirement. First is user requirement, second is system requirement, third is functional requirement, next is non-functional requirement, and last one is domain requirements. So these are the types of requirement through which the customer can give to develop any software project. So, the requirement engineering process is basically a process which is used for requirement engineering, widely depending on the application domain and the people involved and the organization developing the requirement. So, basically, requirement engineering process is a combination of three things: the application domain and the pupils and the organization. So, there are the number of generic activities which are common in requirement engineering process. First activity is requirement elicitation. Second activity is requirement analysis. Third activity is requirement documentation. And fourth activity is requirement review. So this is the diagram or the steps of requirement engineering. So first we have problem statement or feasibility study. In this, we check the problem statement, like what the problem the customer will have. After that, we have requirement engineering phase. So in this phase, we have 4 activities. First is requirement elicitation, second is requirement analysis, third is requirement documentation, and fourth is requirement review. So these all are the activities are comes under the requirement engineering. And at last, after we perform the requirement engineering on any software project, we develop our SRS. So SRS basically is the output, and problem statement or feasibility study is basically the input, or requirement engineering is also called as an input. So this is the process, or this is the steps which we can take in the requirement engineering. So first is requirement elicitation. Requirement elicitation, also known as gathering of requirement. Gathering of requirement means we collecting all the requirement through different methods, and in this requirement are identified with the help of customer and existing system processes. Next is requirement analysis. In requirement analysis, we analyze the requirement through which the requirement which gather in the requirement elicitation, and these requirements start with the requirement elicitation, and after that requirement are analyzed and identify. After that, third is requirement documentation. The documentation is also known as the SRS. Means requirement documentation is also known as software requirement specification. So this is the end product of requirement elicitation and analysis. Uh, After the requirement elicitation and after the requirement analysis, we can perform the requirement documentation. And documentation is very important as it will be the foundation for the design of the software. After the requirement documentation, we have requirement review. In requirement review, the review process is carried out to improve the quality of the SRS. In this, we improve the quality of SRS, and this SRS is generated in the requirement documentation phase. So it may also called as verification. Why verification? Because in this we check the quality of the SRS which is generated in the requirement documentation. So basically, we can simply say that the requirement review is a process of verification, and it should be a continuous activity that is incorporated into the elicitation, analysis, and documentation. So these are the four stages comes under the requirement engineering process. So there are the some methods in the requirement elicitation, and we already discussed that the requirement elicitation is also known as a gathering of requirements, and requirement elicitation is a most difficult activity, and it is the and in this most error prone and most communication intensive aspect of software development. So this is the most difficult step. So in this, we have various methods of requirement elicitation. First method is interview. So in interview, after receiving the problem statement from the customer, first step is to arrange a meeting with the customer. So in this, we discuss with the customer. In the interview, the customer can define their requirement. So during the meeting or interview, both the parties would like to understand each other, and the objective of conducting an interview is to understand the customer expectations from the software, what kind of software the customer can want. So these are the some characteristics. First is there are the two parties in the interview. One is the interviewer and another one is the customer. So the interview can be open-ended interview and structured interview. So how can we select the selection of stakeholders? So there are the 4 points. First is we can select the stakeholders through entry level personnel and through middle level stakeholder, and third is manager or decision maker, and fourth is users of the software. What the users of the software, this is the most important through which we can select our stakeholders. So what are the types of questions we can ask in the interview? For example, the result management system. So if we are talking about the result management system, the questions can like any problem with existing system, any calculation errors, possible reason for malfunctioning, expectation from new system, expectation from the proposed system. So these are the some types of question which can ask in the interview. Second method in requirement elicitation is brainstorming session. So brainstorming session, basically it is a group technique or a group discussion. So in group discussion, we mainly focus on the two terms. First is new ideas. Quickly in group discussion, when the pupils were discussed, so new ideas can come very quickly, and we can also focus on the creative thinking. The pupil can creative. So, and in this group discussion, we prepare a long list of requirements like, the list of requirement can be categorized and can be prioritized and can be pruned. So, idea is to generate views, not to yet them. So, in group discussion, we have the groups of pupils. So, the groups can be the users group and the middle level manager groups and the total stakeholder. So, there are the three types of groups in the group discussions. Third method in requirement elicitation is facilitated application and specification technique, FAST technique. So, this technique is similar to the brainstorming session, and in this we have a team-oriented approach. The persons can work in a team, and it creation of joint team of customer and developer. So in fast technique, the customer and developer can work together. So these are the some guidelines which we have to follow while we perform the fast technique. The first is arrange a meeting at a neutral site, establish rules for participation, inform agenda of the meeting, and we appoint a facilitator to circulate any information, and prepare definition mechanism board, worksheet, like documentation of any meeting, and participants should not criticize or debate. So in the requirement elicitation, in the FAST technique, participants should not criticize to each other and should not debate in any topic. So in this session, each attendee is asked to make a list of objects that are the list of objects are part of environment that surround the system, produced by the system, used by the system, and list of constraint functions and performance criteria. So these are the list which is prepared during the FAST session. So these are the some activities in the FAST session, like every participant present his or list, combined list for each topic, and we have discussion, general agreement, sub teams for mini specifications, and presentation of mini specification, validation criteria, and a sub-team to draft specification. So these are the activities which we perform in the FAST session. Fourth method is quality function deployment. So in quality function deployment, we incorporate the voice of the customer, means what the customer wants. So after that, incorporate voice of the customer in the technical requirement. We translate the voice of the customer in the technical requirement. After that, we documented that requirement. And our prime concern is the customer satisfaction. This is our main goal, that the customer is satisfied. So what is important for customer is customer satisfaction. So we have the three types of requirement: normal requirement, expected requirement, and exciting requirements. So the fourth method is use case approach. So in this approach, we basically design a use case diagram, and this method is introduced by the Ever Jacobson, and use case diagram is gives a functional view. So we have in use case diagram, we have use cases, use case scenario, and use case diagram. So what is use case? A use case is initiated by a user with a particular goal in mind and completes successfully when that goal is satisfied. So there are some components of use case. First component is actor. An actor or external agent lies outside the system model which interact with it in some way. Actor can be a person, can be a machine, and can be an information provider. So after that, another is use case. First component is actor. After that, this oval shape represent the use case, and this arrow represent the relationship between the actor and the use cases. So actors appear outside the rectangle and use case within rectangle provided functionality, and relationship association is a solid line between the actor and the use cases. So this is the example of use case diagram. Basically, this is the actor and this is our use cases, and this is the arrow which shows the relationship, which shows the association among the use cases and the actors. So this is the example of result management system, and we have data entry operator, administrator, student, teacher, and they can maintain student details. Data entry operator can maintain the student detail, can maintain subject detail, and can maintain result detail, and they can also log in. After that, the administrator can log in and can also generate result report and can also view the result, and at last the student or teacher can only view the result. So this is the use case diagram. Second is requirement analysis. So second activity of requirement engineering process is requirement analysis. So these are the steps which comes under the requirement analysis. First is draw the context diagram. Second is develop prototype. Third is model the requirement, and fourth is finalize the requirement. So this is the context diagram. Context diagram is a simple model that defines the boundaries and interface of the proposed system. Like this is our result management system. They define the boundaries and interfaces of the proposed system. Like this is the marks entry operator, administrator, subject information entry, student information entry, mark sheet generated, student performance report generated, student information report generated. So are these all are provided the interfaces. Our second step is development of prototype. Prototype is simply a dummy. So prototype helps the client to visualize the proposed system and increase the understanding of the requirement, and prototype may also help to take the final decisions. Third step is model the requirement. After the prototype, uh, this process usually consists of various graphical representation of function, data entities, external entities, and the relationship between them. So such models include like DFD, data flow diagram, ER diagram, entity relationship diagram, data dictionaries, state transition diagram. So all the diagrams, all the models are comes under the model the requirement. After that, finalize the requirement. After designing the diagram, after the modeling has done, the requirement inconsistencies and ambiguities have been identified and corrected. So flow of data among various modules have been analyzed. So now finalize and analyze requirement. And the next step is to document these requirements in prescribed the format. After modeling the data, we finalize and analyze the requirement and to document these requirements. So this is the DFD diagram. DFD diagrams show the flow of data through the system, and in the DFD diagram, all names should be unique, and it is not a flow chart, and it suppresses the logical decisions, and it also differ the error conditions and handling until the end of the analysis. So these are the some notations like this symbol is called as data flow, and this is the connect process, and this circle symbol is known as a process, and they perform some transformation between the input data to the output data, and this symbol is called as source or sink. And source or sink, source of system input to the sink of system output, and this symbol is called as a data store. In this they show the repository of data. So there are the different types of DFD like 0 level DFD, 1 level DFD, and 2 level DFD. So a 0 level DFD is called fundamental system model or the context model, and in this we have only single bubble or the single process with input and output data indicating by the incoming and outgoing arrows. But in level 1 DFD, in this we have more than one processes, like we can show the flow of data from one bubble to the another bubble. So simply in level 0 DFD we have only one process, but in level 1 DFD we can have more than one process. So this is the example of data flow diagram of inventory management system. Like they show the, in this diagram, we have three processes: first process, second process, and third process. And this shows the data store like invoices. In this, we store the information. In customer, we store the customer information. In orders, we have the information of the customers' orders, and these arrows show the incoming and outgoing. These are the incoming edges and outgoing edges. So this is the example of DFT. After that, we have data dictionary. Basically, data dictionary is simply a repositories to store the information about all the data items which we used in the DFT. So it store the information like the name of the data item, the other name for the items, description of the item, related data item, range of values, data flows, data structure, definition. So these are the some notations of the data dictionary, like x is equal to a plus b. It means x consists of both the element a and b. X a divided by b means x consists either a or either b. X is equal to in bracket a, it means it consists an optional data element a, and x is equal to y of a, it means x consists of y or more occurrences, and x is equal to in bracket a of z, it means x consists of z or fewer occurrences. So these are the some notations which we used in the data dictionaries. Next diagram is ER diagram, entity relationship diagram. So it is a detailed logical representation of data for an organization, and it uses three main constructs. First is entity, second is relationship, third is attributes. First is entity. Entity is a fundamental thing about which data may be maintained. So entity is means it is an object. After that, like this policy is an entity and customer is an entity. This is an example of insurance company that offer both home and automobile insurance policies. So policy, we have home policy or automobile policy, and customer, we have individual customer, or the customer can have the businesses. So these are the entities. So next is relationship. So a relationship is a reason for associating two entity types. Like this is the symbol of the relationship, the diamond symbol, and it shows the relationship between two entities like customer and policy. So this shows the relationship between the customer and policy. It means customer insured by the policy and policy made against policy claim. So this shows this relationship shows the relationship between the policy and policy claim. So the relationship is represented by the diamond notation. Third is degree of a relationship. It is the number of entity type that participates in that relationship. Means like we have unary relationship. There are three types of degrees: unary relationship, binary relationship, and ternary relationship. In unary relationship, one person is married to one person, but in binary, employee, there is one employee manages the many employees, one to many relationship. And in this we have like one employee is assigned to one parking place, one product line contains many product, and many students register for many courses. So these all are the three relationships, like one to many, and many to many. So these are the binary relationships. Next is ternary relationship. In ternary relationship, we have like a ship. This is the relationship. This shows the relationship between the vendor, part, and warehouse. So this is the example of ternary relationship. Next, after the entities and relationship, next is attribute. So each entity type has a set of attributes associated with it. So basically, attribute represent the characteristics of any entity. So the attribute is represented by the oval shape. For example, we have an entity which is called student, and these all are the attributes of the student entity, like student ID, student name, student address, and student phone number. So this is how we can design the entity relationship diagram. Third is requirement documentation. After the requirement elicitation and after the requirement analysis, we have requirement documentation, and requirement documentation is written, serves many purposes depending upon who is writing it. And so requirement documentation is written by the developer also, and written by the customer also, and they also serve as the contract between the customer and the developer. So basically we can say that the requirement documentation is an agreement between the customer and the developer. So why we need the software requirement specification? Because the problem is that the client usually does not understand software or software development process, and the developer often does not understand the client problem and application area. So in this there is a problem between the understanding the software customer problem. So there is a they create a communication gap between the developer and the between the uh, software developer and the customer. So to fill this gap, we can use the so we can need software requirement specification. So this causes a communication gap between both the parties which is involved in the development of the project. So a basic purpose of software requirement specification is to bridge the communication gap between the developer and the customer. So requirement documentation. So while we developing the SRS, we have to focus on the basic issues which are related to the SRS. Means what the nature we have. So nature of SRS are: First, we have functionality. Second is external interfaces. Third is performance. And fourth is attributes. They have some attributes. And last one is design constraint imposed on an implementation. So these all are the parameters which we have to think, which we have to focus while developing the SRS. So these are the some characteristics of a good SRS. So an SRS should be correct, unambiguous, complete, consistent, ranked for important and stability, verifiable, modifiable, and traceable. So these are, if in any SRS, if we these have all the activities, then this is called as a good SRS. Fourth is requirement validation. Fourth activity in requirement engineering process is requirement validation. After the requirement elicitation and after the requirement analysis and after the requirement documentation, the last step is requirement validation. So requirement validation is an iterative process which takes place throughout the life cycle of the project. So while developing the whole software project, in every stage, we can perform the validation. So during elicitation, during analysis and specification, we should constantly be questioning and clarifying the data given to you in order to check its validity. Given to you in order to check its validity. So we can basically check the document for the completeness and consistency. Means we can check whether our document is complete or not, whether our document is consistent or not, provide the conformance to standard, the standard like IEEE standard, ISO standard. So these are the standard guidelines, whether the document follows or not. Next is requirement conflict. We can check the conflict. After that, technical errors. If we have any error in the software development, then we can easily remove that, tackle with that error. Next is ambiguous requirement. If we have any ambiguity in the software project, then we can check the document for these categories. So basically, this is the steps or the procedure which we have to follow during the validation process. So in validation process, we have list of problems and we have SRS document. After that SRS document and organizational standard like IEEE standard and ISO standard. So we have to follow these standard guidelines. After that, we have organizational knowledge, like we have some knowledge about any customer, about any product. So we can also store these all our information in the validation process, and we can, after that, after collecting these three SRS document, organizational standard and organizational knowledge, we can validate the process. After that, we can create a list of problems. After the generation of list of problems, and after that, they can generate the approved actions. So the problems are generated and the approved actions can also provide through the requirement validation process. So this is the requirement review or requirement verification process. How can we verify our software product? First of all, we have to plan a review. Plan a review means how can we review our software product? After that, after planning the review, we distribute the SRS document. Distribute SRS document like in our software developer team, we have multiple persons. So we distribute these review to many software developers in the team. After that, we can read the documents. After distributing the SRS document, the software developers can read this document, and after reading, they organize organized review about the software product, and they give some actions which we have to follow-up actions. And if we have any changes, if we have any modifications, then we can revise the document. In revise the document, we can make any changes. After that, we can generate a new document. So there is the process between the of requirement verification and validation. In requirement validation, we check that the right product is being built, and it also ensures that the software being developed will satisfy its stakeholders or not. And we can also check the software requirement specification against stakeholders' goals and requirements. So in this, we can check the right product is being built. But in requirement verification, we can check that the product is being built right. Uh, so it also ensures that each step followed in the process of building the software yield the right products. And it also check the consistency of the software requirement and the specification artifacts and other software, and also the development products like design implementation against the specification. So this is the diagram of the verification and validation. First, we have to know about our goals and requirement, and after that we can generate our requirement specification. After requirement specification, we can create a software design. After designing, we can generate our system. So this is the process of requirement verification and validation, and these all are the steps of the requirement engineering process. Thank you.